Now we'll be working on chapter 7 questions, true or false statements. Number 31, if you decide to reject a null hypothesis, then you can support the alternative. Yes, that statement is true. And let's move on to the next question. All right. Match the statement with the graph. So mu greater than 7, that will be greater than 7 and with an open circle. So that should be A. And that is the alternative hypothesis. So the null will be mu less than or equal to 7. And that should be F, not F, sorry, B, right here. Next. A laptop manufacturer claims that the true mean of a battery is more than 9 hours. More than 9 hours, guys, will be greater than 9. So the null hypothesis will be less than or equal to 9. Let's see which one is that. So that's F. And the claim is in the alternative because it says more than 9. Okay, write the claim as a mathematical statement. According to a recent survey, 7% of college students use student loans. So P equals 70%. So for the null will be equal, for the alternative will be not equal, and the claim is in the null hypothesis. F. Describe type 1 and type 2 errors in there. A shoe store claims, okay, let me just get a notepad here. Shoe store claims that no more than 30% of its new customer will return to buy their next pair. Okay, what is type 1 error? Type 1 error is when you reject the null hypothesis when it is in fact true. So no more than 30% means less than or equal to 30%. So a type 1 error will occur when the actual proportion of customers who will return to buy their next pair of shoes is less than or equal to 30%, but you reject this statement. So it is A. For type 2 error, guys, it's type 2 error will happen when you fail to reject HO when it is false. So it will occur when the actual proportion of a new customer is not less than or equal to 0.30. So it is more, but you fail to reject this fact. So a type 2 error will occur when the actual proportion of a new customer return to buy their next pair of shoes is more than 30%, but you fail to reject HO. So that's the definition here. Same thing here, if you can see, guys. A golf analyst claims that the standard deviation of the 18-hole score of golf is at most 3.7. At most, guys, means less than or equal to 3.7. So the claim is in the null hypothesis. What's type 1 and type 2? The null hypothesis is the standard deviation of the 18 holes is at most 3.7. And you write it as sigma less than or equal to 3.7. What is the alternative? The alternative will be sigma greater than 3.7, and you can see right that. If the alternative is greater than, then it is a right tail test. Okay. Let me just remove this. Determine whether the claims stated below represent the null hypothesis or the alternative hypothesis. If a hypothesis test is performed, how should you interpret a decision that rejects a null hypothesis or fail to reject a null hypothesis? A scientist claimed that the mean incubation period for the egg of species is at most 41 days. Since the claim contains a statement of equality, it represents the null hypothesis. At most, it has equality in it, less than or equal to. How should you interpret a decision that rejects the null hypothesis? If you reject the null hypothesis. So then you say there is sufficient evidence to reject the claim because the claim is in the null hypothesis. If you fail to reject the null hypothesis, then you say there is not sufficient evidence to reject the claim. The reason why I'm using the word reject because the claim is in the null hypothesis. Okay, your medical research team is investigating the mean cost of 30-day supply of a certain heart medication. Pharmaceutical companies think that the mean cost is more than 51. Okay, so more than 51, you want to support this claim. So mu1 will be mean is greater than 51, and the null hypothesis will be mu less than or equal to 51. This is the p-value, and I would like you to compare it with the following levels of alpha. So if alpha is 0.01, how would you compare this p-value? If alpha is 0.01, the p-value is 0.0499 is bigger than alpha. So if it is bigger than alpha, you fail to reject HO. For 0.05, it is less. 0.0499 is less than alpha, so you reject HO because the p-value is less than alpha right here. And it is less than 10% as well, p-value, so you reject HO because the p-value is less. Find the p-value for the indicated hypothesis test with the given standardized test statistic. Decide whether to reject HO or fail to reject HO. So we have a right tail test, Z is 1.25, and you need to find the p-value. Remember, guys, if it is a left tail test, the p-value is the area to the left of the test statistic. If it is a right tail test, it is the area to the right. So we're going to find the area to the right of the test statistic. Let me get that. So the p-value is the area to the right of Z equal 1.25. And to find it, we need normal CDF. So we're just going to go to second variable, normal CDF. And you can see, guys, 1.25 should be the lower. Upper is a million or billion, whatever. And then 0.1. So your answer is 0.1056. This is the p-value. Okay. State your conclusion. Since it is 1.1056, which is bigger than alpha, you fail to reject HO. Use your calculator display to make a decision to reject or fail to reject HO. Alpha is 0.05. Here is the p-value, guys. You can see it right here. 0.0198, which is less than alpha, you reject HO. Use technology to help you test the claim about the population mean at the given level of significance. Assume population is normally distributed. So the claim is mean greater than 1250, alpha is 0.02. You have sigma. If you have sigma, guys, you know it's a z-test. So we're gonna run a z-test here. It's a number 1. Enter. Okay. I have summary, so keep it at stats. Okay, mu0, we're testing against the value 1250. Let me run the test and then I'll show you how to fill in the blanks. Sigma is 210.30, 201.32. X bar is 1265.66. N is 250. And what is the alternative? It's a greater than. And now we can hit calculate. So this is C, the null and the alternative. The standardized test statistic Z is 1.23. Just put it right here. The p-value is 0.1094. You just put it right there. And what is your conclusion? Alpha is 0.02. You know the p-value is bigger than alpha, so fail to reject HO. There is not enough evidence to support the claim. Why did I use the word support? Because the claim is in HA, is in the alternative hypothesis. In a random sample of 90 8th grade students scored on National Mathematics Assessment has a mean of 279. The test result prompts a state school administration to declare that the mean score for the state 8th grade on the exam is more than 270. Assume that the population standard deviation is 36. Once he assumed that we have the population standard deviation, then you have to use what we call a z-test, guys. Just don't forget that. Sigma known. We're going to be using a z-test. All right, so let's bring the calculator up. Stat, tests, z-test. State the null and the alternative first. Well, since it says more, so it's more than 270, it will be E, as you can see. And the claim is in HA. And to find the rest of the values, so you put 270 here. And then what do we have? The sample of 90 has a mean of 279. And what's sigma? 36. 279. Sample is 90. And we want more than. And guys, you just do this, calculate. So Z is 2.37, p-value 0.0089. And let me just write the p-value here. It's less than alpha, of course, reject HO. And at the 6% level of significance, there is enough evidence to support the administration claim. I use the word support because the claim is in HA. Remember, when we reject HO, we can support the claim if it is in HA. Nutrition claims that the mean tuna consumption by a person is 3.5 pounds per year. A sample of 90 people show that the mean tuna consumption by a person is 3.2 pounds per year. Assume population standard deviation is 1.18. Again, z-test, guys. So this is also a z-test. So stat, because he gives us the population standard deviation. Okay, so mu0. We're testing against 3.5. And they say is 3.5. So the null will be equal and the alternative will be not equal to. So that will be D. And the claim is in HO, remember that. So population standard deviation is 1.8. X bar is from the sample of 90, we got 3.2. Sample size is 90. Is it 90? Yeah. And then not equal to right here. So make sure to select it and press enter and hit calculate. So Z is negative 1.58 and the p-value is 0.1138, guys. When what is alpha? Alpha is 0.07. That's bigger than 0.07, so you fail to reject HO. And there is not enough evidence to reject the claim. So there is not enough evidence to reject the claim. Why did I use the word reject? Because the claim is in the null hypothesis. Next. Okay. Assume that the population is normal and the population standard deviation 9200. Here, guys, you can put this data in L1 and run a z-test, or you can use StatCrunch. Watch, I'm going to show you how to open in StatCrunch and use StatCrunch. But remember, population standard deviation is given, so we need to use z-test. You go to stat, z-stat, one sample with data. Oops, let me see, one sample with data. Okay, select the variable. and put the standard deviation value, which is what here, 9200. Let me just bring this back. So you have to put the value of the standard deviation, 9200, right here. And what we're testing, what's the null and the alternative hypothesis here? They claim that the mean salary is more than 81,000. So let me see, more, it will be C. Okay, and now I'll take you back. We're testing against 81,000. You put it here and you change this one to greater than. Just worry about the alternative. Just make sure it has the correct sign. And now you can compute. The Z is 2.08 and the p-value is 0.0185. That's how you do it. Use it. So what is alpha? Alpha is 1%. So actually the p-value is bigger than alpha. You fail to reject HO and you cannot support the claim. So there is not enough evidence at the 1% level of significance to support the claim, which is A. Now, why did I use the word support? Because the claim is in HA. And look, he asks if you can support. So he uses the word support here. Okay, now we have the claim mu is greater than 77. Let's select the null in the alternative. That would be C. And he gives you S. Once he gives you S, it's a t-test. So we're going to go to t-test right now. Clear, stat, t-test. Watch, guys. And we have mu0 against 77. And let's see what the rest of stuff he gives us. X bar is 77.8. S is 3.7. N is 23. And greater than, we need to greater than, it's the last one. Make sure to hit enter when you select it and hit calculate. And now I get T is 1.037 and the p-value is 0.1555, which is of course bigger than alpha. So we fail to reject HO and you cannot support the claim. A consumer group claims that the mean minimum time it takes for a sedan to travel a quarter mile is greater than 14.9. A random sample of 24 sedans has a minimum time to travel a quarter of a mile of 15.4 and a standard deviation of 2.9. Okay, so this is a t-test, guys, because he gives us the sample standard deviation. So we have X bar is 15.4. We have S to be 2.09 seconds, and N is 24, and alpha is 0.10, and we're gonna run a t-test. So let's run the t-test right here. Put it on. But before we do that, let's select the null in the alternative hypothesis. So he says greater than 14.9. So mu less than or equal to, that should be in the alternative, in the null, 14.9. And here it's going to be mu. You have to pick the proper letter here. Greater than, where is the greater than? 14.9. And where is the claim is in the alternative hypothesis, because it says more than, greater than. Now I can go back and run the test, guys, together. Let's do that. So stat, tests, t-test, not data. So mu0, we're doing it 14.9. X bar is 15.4. S is 2.09. N is 24, and we need greater than. You can do calculate or draw, either one is good. So T is 1.17, and the p-value, guys, is 0.1266, which is bigger than 10%, so you fail to reject HO. So if I move this, so fail to reject HO because the p-value is greater than alpha, and since the claim is in the alternative, you cannot support the claim. There is not enough evidence at the 10% level of significance to support the claim that the mean minimum time it takes for student to travel a quarter is greater than 14.9 seconds. All right. You receive a brochure from a large university. The brochure indicates that the mean class size for full-time faculty is fewer. Fewer means less than 32. So let's select the null and the alternative. That would be E. And the claim is in the alternative. The results are shown in the table. At alpha equal 5%, can you support the university claim? Look how we can do this in StatCrunch. Open in StatCrunch. Go to stat. T-stat. You didn't say population standard deviations. T-stat. One sample with data. Select the sample. And go to the hypothesis test and just put the alternative hypothesis. Whatever the value is. We're doing it against 32. And they say it's less than 32. So 32, and then we select the alternative. Now probably you're wondering that should be for us greater than or equal, but remember the null hypothesis statement of equality. So StatCrunch, just put the equal sign here. And then hit compute, and here's the test statistic, negative 2.57, 0.0099 for the p-value. If you guys want to use the calculator, here's what you do. You have to enter the data stat edit, put it in L1, and then after you're done with that, you go to stat, tests, t-test, data, U0 is against 32, we're doing against class size of the, your list is L1 frequency, leave it at that, and then we need less than. And then you just go and hit calculate. So you get the p-value 0.0099, which is less than alpha. So you reject the null hypothesis and support the claim. So reject HO because the p-value is less than the level of significance. And what's your interpretation? Remember, guys, the claim is mu is less than 32. We reject HO, we support the claim. So at the 5% level of significance, there is sufficient evidence to support the claim. Not more than, it's less than. So read the whole thing. The sufficient evidence, there is sufficient evidence, is fewer than 32. Right here, D. Probably you're not seeing D here with me. Just one sec. So at the 5% level of significance, there is sufficient evidence to support the claim that the mean class size is less than 32. Remember, guys, we rejected HO because the p-value was less than alpha, and we support the claim because the claim is in HA. 49. A research center claims that 28% of adults in a certain country would travel into space on a commercial flight if they could afford it. In a random sample of 1,200 adults in that country, 31% said that they would travel into space on a commercial flight if they could afford it. At alpha equal 1%, is there enough evidence to reject the researcher claim? So they say it is 28%. So P is 28%. And P not equal to 28% is the alternative. Identify the claim. The percentage of adults in the country who travel into space is 80. It's D here, and you just put 28% right there. Let P be the proportion of successes where a success is an adult in the country who would travel into space on commercial flight if they could afford it. State HO and HA. So as we said, HO is P equals and HA is P not equal. So 0.28 and not equal 0.28. And remember, the claim is in HO, guys. So if claim P is 0.28 and HA P is not equal to 0.28, and this is where the claim is. So this is a proportion test. Let's see. Use technology to find the p-value and then make decisions. So let's bring the calculator. Clear, stat, tests. It's one prop z test number 5. It's a proportion test. Now we're doing proportion. P0 is against 0.28. We're doing a 0.28, guys. X is the number of successes. He didn't give me X, but he says 31% of them would travel. 31% of how many? 1200. So you guys just put 0.31 times 1200. But if this answer turns out to be a decimal, make sure to round it. It's not. It's going to be okay. So an N is 1200. And we have equal and not equal. And then we're going to hit calculate. So Z is 2.31 and p-value, guys, is 0.0206. So p-value, so this is Z, this is the p-value. And what's alpha here? What did he say? Alpha 0.01. So actually p-value is bigger than alpha. And p-value is bigger than alpha, you fail to reject the null hypothesis. And then if you fail to reject the null hypothesis and the claim, you fail to reject HO and the claim is in HO, you say there is not enough evidence to reject the claim. Let's find it. So there is not enough evidence to, remember what I taught you the other day. If the claim is in HO, you use the word reject to reject the researcher claim. Last exercise. A humane society claims that less than 64% of households in a certain country own a pet. So less than 64%, that's the claim, own a pet. In a random sample of 400, that's N. 244 say they own a pet, that's X number of successes. At alpha equal 1%, is there enough evidence to support the claim? Once he asks you if you can support the claim, that means the claim is for sure in HA. So you want to see checklist, that would be right here. 64%, 0.64 and 0.64 right here. Use technology to find the p-value. Let's find the p-value here. So stat, tests, one prop z test. We're doing against 0.64. And what is X, guys? We said X is 244 and N is 400. And the proportion, we need the alternative hypothesis. This is the alternative hypothesis, which is less than, right? We said less than 64, yeah. And then hit calculate or draw, if you want to do a draw now this time. Okay. So Z is negative 1.25. Let me just write it down. I'm going to complete this problem. And let's see what the p-value is. Let me bring it back. P-value, guys, 0.1056. And the p-value is bigger than alpha. Alpha, what is alpha here? 1%. Bigger than alpha, fail to reject HO. And if you fail to reject the null hypothesis, you cannot support the claim. So there is not enough evidence to support the society claim. That concludes the review for the test.